Good evening, children.
Good evening.
Good evening, ma'am.
Good evening. So let's recall the definitions of the special quadrilaterals, starting with the parallelogram. We saw them in the last class. So a parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. This is the definition of a parallelogram. A quadrilateral in which both the pairs of opposite sides are parallel. Now, when a quadrilateral is identified as a parallelogram, there are other properties which it has. So in a parallelogram, opposite sides are equal. Both the pairs of opposite sides are equal. In a parallelogram, both the pairs of opposite sides are equal. In a parallelogram, both the pairs of opposite angles are equal. Both the pairs of opposite angles are equal. Now, a quadrilateral has two diagonals. Each diagonal of the parallelogram divides it into two congruent triangles. Each diagonal. Now, if you consider this diagonal, the parallelogram is divided into two triangles with respect to this diagonal. These two triangles are congruent to one another. See, if you fold the parallelogram along this diagonal, the triangles will not coincide. If you fold the parallelogram along this diagonal, they'll not coincide. You need to cut it along the diagonal and rotate the triangle and place it in a particular way, then they'll coincide. So you can just try that. You can make a paper cutout of a parallelogram and cut it along the diagonal, and you'll see that you should just turn it. Because as it is, if you fold, what will happen? As it is, if you just fold it along this, what happens is this side will coincide with this side. But these two sides are not equal. Opposite sides are equal. If you simply try to fold it like this along this crease, if you try to fold the parallelogram, because we understand that these two triangles are congruent to each other. Congruency meaning they're identical triangles. So if you try to fold the parallelogram along this diagonal, what happened? This side will coincide with this side, and this side will coincide with this side. No, but they can't coincide. No, because opposite this side and this side, they're not equal. Adjacent side, they're not equal. They'll not coincide. So you have to cut the parallelogram along this diagonal, rotate it, and when you place the triangle in such a way that this side coincides with this side and this side coincides with this side, then you will see that the triangles are congruent. So simply folding the parallelogram along the diagonal, you will not see the triangles, coinciding, the sides of the triangle coinciding. No, but they are congruent triangles. Okay. So in a parallelogram, we'll see it again. In a parallelogram, the definition of a parallelogram is the definition of a parallelogram is in a quadrilateral. If both the pairs of opposite sides are parallel, then it is a parallelogram. If a quadrilateral is identified as a parallelogram, then these are the properties it has. In a parallelogram, opposite sides are equal. Both the pairs of opposite sides are equal. In a parallelogram, both the pairs of opposite angles are equal. A diagonal of the parallelogram divides it into two congruent triangles. Diagonals of a parallelogram bisect each other. Diagonals are not equal. Diagonals will not be equal. In a parallelogram, diagonals are unequal, but they bisect each other. Bisect each other meaning? So if the length of this diagonal is 8 centimeters, it will be 4 here and 4 here. And if the length of this diagonal is 10 centimeters, it will be 5 here and 5 here, which means this point is the midpoint of both the diagonals. This point is the midpoint of both the diagonals. That's what is meant by the diagonals bisect one another, bisect each other. So one diagonal cuts the other diagonal into two equal parts. Bisect each other, meaning they cut one another into two equal parts. So ABCD, diagonal AC cuts the diagonal BD into two equal parts. Diagonal BD cuts the diagonal AC into two equal parts. So they bisect one another. They bisect each other. So diagonals of a parallelogram bisect each other. Diagonals are unequal. Diagonals are unequal, but they bisect each other. Diagonals are not perpendicular. Diagonals don't meet at right angles. It is not 90 degrees here. Okay. So opposite sides equal, both the pairs of opposite sides equal, both pairs of opposite angles equal, diagonals unequal, diagonals bisect each other, diagonals do not meet at right angles. A diagonal divides the parallelogram into two congruent triangles. Listen, we have more. Listen. Now, when we talk about the diagonals, now consider this diagonal. This diagonal will not bisect the corner angles. See, like if this angle is, say 80 degrees, this also will be 80, no? Because opposite angles are equal. In a parallelogram, opposite angles are equal. So if this is 80, this is also 80. Now this diagonal will not bisect the corner angles. It will not bisect. So maybe it's 50 here and 30 here. Then it will be 30 here and 50 here. Because alternate angles are equal, no? Alternate angles are equal. Parallel line, transversal, parallel line, alternate angles are equal. So see, you will see that the diagonal will not bisect the corner angles. It will not bisect the corner. Similarly, it will not bisect the corner angles. Similarly, the other diagonal. So if this is 80, this has to be 100. If this one is 80, this has to be 100. Let me change because it doesn't look like 80, this one. Let me make this one 100. Okay. So supposing this is 100, so maybe this is 70, this is 30. So it will be 30 here and 70 here. So if this is 100, if this is 100, this has to be 80. Because adjacent angles are supplementary. It's a parallelogram, parallel line, transversal, parallel line. Adjacent angles are supplementary. Parallel line, transversal, parallel line. Co-interior angles are supplementary. Angles on the same side of the transversal, they are supplementary. So if this is 100, so this has to be 80. It will not be 40-40. It will not be 40-40. So maybe 30 here and 50 here. Then it will be 30 here and 50 here. Diagonals of a parallelogram do not bisect the corner angles. Okay. So talking about a rhombus, so this is about a parallelogram. Now talking about a rhombus is a special parallelogram. A rhombus is a special parallelogram. A rhombus is a parallelogram in which all sides are equal. In a parallelogram, only opposite sides are equal. Now, in this parallelogram, if all the sides are equal, then it's a rhombus. It is a parallelogram. Further, a special name is rhombus. A rhombus is a parallelogram. A rhombus is a parallelogram. So it has all the properties of a parallelogram, plus some properties are modified. It has all the basic properties of a parallelogram, but some properties are modified. Like, see, in a parallelogram, only opposite sides are equal. But in a rhombus, all sides are equal. Which also means opposite sides are equal, right? Which also means opposite sides are equal. Okay. Now, talking about the angles, in a rhombus, like in a parallelogram, in a rhombus, opposite angles are equal. Opposite angles are equal. So in a rhombus, all the sides are equal. A rhombus is a parallelogram in which all sides are equal. That's the definition of a rhombus. A parallelogram in which all the sides are equal is called a rhombus. So if you have to prove that a quadrilateral is a rhombus, okay, if you have to prove that a quadrilateral is a rhombus, you have to first prove it's a parallelogram. And then in the parallelogram, adjacent sides are equal, so it's a rhombus. So we'll see those proofs. If you're given a quadrilateral with some information and you have to prove that it's a rhombus, you need to first prove it's a parallelogram. And then in the parallelogram, adjacent sides are equal, so it's a rhombus. So that's the path. Whenever you have to prove that a quadrilateral is a rhombus, rectangle, or a square, you have to first prove that they are parallelograms. Then in the parallelogram, if all the sides are equal, it's a rhombus. If in the parallelogram, if one corner is a right angle, then it's a rectangle. In the parallelogram, if all sides are equal and one angle is a right angle, then it's a square. If all sides are equal, rhombus. If one angle is a right angle, it's a rectangle. If both these put together in a square, both these conditions put together in a square. So in a parallelogram, if all the sides are equal and one angle is a right angle, then it's a square. So to prove that a quadrilateral is a rhombus, rectangle, or a square, you need to first prove it's a parallelogram. So coming back to a rhombus, in a rhombus, opposite angles are equal. Opposite sides are equal. All sides are equal. In a parallelogram, only opposite sides are equal. In a rhombus, all sides are equal. All the sides are equal. Diagonals are unequal. Like in a parallelogram here, diagonals are unequal. Diagonals bisect each other because in a parallelogram it bisects each other. So diagonals bisect each other. Diagonals are unequal. They bisect each other, but at right angles. At right angles. Diagonals are not of the same length. In a rhombus, the diagonals will not be of the same length. Diagonals are unequal. Diagonals bisect each other at right angles. In a parallelogram, diagonals are unequal. In a rhombus, diagonals are unequal. Parallelogram, diagonals bisect each other. Here also, diagonals bisect each other. In a parallelogram, diagonals do not meet at right angles. Here in a rhombus, the diagonals meet at right angles. Now, we understood that in a parallelogram, the diagonal does not bisect the corner angles. In a rhombus, the diagonal bisects the corner angles. It does bisect the corner angles, which means, let's just take some measure. Say this is 60 degrees. Okay, this angle is 60. It will be 30-30 like this. And since opposite angles are equal, this also has to be 60. It's bisected 30-30. So if this is 60, this angle has to be 120. This one has to be 120 because 120 plus 60 is 180. So this has to be 120. The angle is bisected by the diagonal. So it will be 60 here and 60 here. And since opposite angles are equal, this also will be 120. It will be 60 here and 60 here. And you can see that the angle sum property of a triangle is also satisfied. See here, 90 plus 30 plus 60 is 180. Is 180. So this is the very special difference between a parallelogram and a rhombus. In a parallelogram, diagonals do not meet at right angles. In a rhombus, the diagonals meet at right angles. That's a difference. And then in a parallelogram, the diagonals do not bisect the corner angles. In a rhombus, the diagonals bisect the corner angles. And of course, other things, no? In a parallelogram, only opposite sides are equal. Here, all sides are equal. These are the special differences. They meet at right angles, they don't meet at right angles. Diagonals bisect the corner angles, do not bisect the corner angles. So these are the very special differences between a parallelogram and a rhombus. So if you have to prove that a quadrilateral is a rhombus, you have to prove it's a parallelogram. And then in the parallelogram, since all the sides are equal, it is a rhombus. That's the definition of rhombus. You just have to see if you're asked, y is 10, a composite number. Y is 10, a composite number. Okay, so you will use the definition of a composite number. What is a composite number? A number that has more than two factors is called a composite number. A number that has more than two factors is called a composite number. So when you're asked, this question, why is 10 a composite number? So you'll use a definition of a composite number. A composite number is a number that has more than two factors. So the factors of 10, 1, 2, 5, and 10 itself. Yeah, so it has more than two factors. So it's a composite number. So in the same way, so that we use a definition. We use the definition to justify why 10 is a composite number. In the same way, when you have to prove that a quadrilateral is a rhombus, use the definition. What is a rhombus? It's a parallelogram in which all sides are equal. So you have to prove that the quadrilateral is a parallelogram and then go on to prove that all the sides are equal and hence it's a rhombus. Now, by the definition, we understand that in a parallelogram, both the pairs of opposite sides are parallel. But a parallelogram has other properties, right? Okay. So what are the different criteria which help you to prove that a quadrilateral is a parallelogram? The different criteria under which a quadrilateral qualifies to be a parallelogram. What are the different situations in which a quadrilateral qualifies to be a parallelogram? Let's see them one by one. So by the definition, this is criteria. Criteria for a quadrilateral to be a parallelogram or to be called a parallelogram. Okay, so both, I'll share all the notes, children. Don't write down anything now. You can take running if you are like good at taking notes as I'm telling, you can. I'm not saying don't write, but I'll be sharing the notes with you is what I'm trying to say. So by the definition, in a parallelogram, both pairs of opposite sides are parallel. This is the definition. Now, apart from this, in a quadrilateral, if both pairs of opposite sides are equal, then also it's a parallelogram. If you can prove that in a quadrilateral, both the pairs of opposite sides are equal, then also it's a parallelogram. If the definition is the first one. If you can, because see, what you can prove is based on the information. Based on the information, sometimes you may not be able to prove that opposite sides are parallel. Based on the given information, you will be given some limited information, right? You'll be given a quadrilateral with some limited information. With the help of that, maybe you will not able to prove that opposite sides are parallel, but possible that you are able to prove that opposite sides are equal. So that's enough. If both the pairs of opposite sides are equal, if you can prove that both the pairs of opposite sides are equal, then it's a parallelogram. Automatically, the opposite sides will be parallel also. Opposite angles equal. If you can prove that both the pairs of opposite angles are equal, both pairs, okay? If you can prove that both pairs of opposite angles are equal, then it's a parallelogram. Diagonals bisect each other. Diagonals bisect each other. Then also it's a parallelogram. Or one pair of opposite sides parallel and equal. Parallel and equal. So if you can prove that both the pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. If you can prove that both the pairs of opposite sides are equal, then the quadrilateral is a parallelogram. If you prove that both the pairs of opposite angles are equal, then the quadrilateral is a parallelogram. If you can prove that the diagonals bisect each other, so you'll be like, how can you prove that diagonals bisect each other? Nothing. If you can prove that, like you prove that this triangle is congruent to this triangle. So CPCT will get this side is equal to this side. Then you prove that this triangle is congruent to this triangle. So CPCT, you will get this side is equal to this side. So what is bisect each other? That means both the diagonals have the same midpoint. If you prove that this is equal to this is equal to this, you can get it from one congruency itself. Just see. So when you prove that these two triangles are congruent to each other, CPCT, you can get the result. This side of this triangle is equal to this side of this triangle. Also, from this itself, you can say that this side is equal to this side, CPCT. So if you prove that through congruency, you can prove. If you prove that this side is equal to this side and this side is equal to this side, that means the diagonals bisect each other. They have the same midpoint. They bisect each other. Then also it's a parallelogram. It's enough. If you just show that the diagonals bisect each other, it's a parallelogram. You don't have to prove all of these. Any one of this, if you can prove any one of this, the quadrilateral is a parallelogram, not all. So if you simply prove that the diagonals bisect each other, the quadrilateral is a parallelogram. And you will see that it will have all the other properties of a parallelogram. And also, the last one, in the quadrilateral, if you can prove that one pair, any one pair of opposite sides are parallel and equal, any one pair parallel and equal, then also it is a parallelogram. So you can use any one of these criteria to show that a quadrilateral is a parallelogram. Mostly we have information to show that opposite sides are parallel. So it's a parallelogram, we say. You can use any one of these. If you can prove any one of these criteria, the quadrilateral is a parallelogram. So once you prove it's a parallelogram, from there, if you prove all sides are equal, it's a rhombus. If you prove one angle is a right angle, one angle is 90 degrees, then it's a rectangle. If you can prove that all sides are equal and one angle is a right angle, then it's a square. Okay. Now coming to a rectangle. So a rectangle is a parallelogram in which one angle is a right angle. A rectangle is a parallelogram. See, don't imagine this, okay? Oh, she says it's a parallelogram in which one angle is right angle. So it will be like this. No. If one angle is a right angle, it becomes like this. And this one is a parallelogram. This one is a parallelogram because opposite sides are parallel. Because opposite sides are parallel. We should not imagine something like this. like this with 90 degrees here. No. The sides become perpendicular. The adjacent sides are perpendicular to each other like this. Okay. So rectangle. Rectangle is a parallelogram in which one angle is a right angle. Now the properties of a rectangle is, we are more familiar with the rectangle than rhombus, parallelogram, trapezium, and kite. Okay, so we'll see the special properties. The general things, opposite sides equal, corners, right angles. Now, in a rectangle, diagonals are equal. In a rectangle and in a square, diagonals are equal. In a rhombus and in a parallelogram, diagonals are unequal. In a rhombus and in a parallelogram, diagonals are unequal. In a rectangle and in a square, diagonals are equal. I think we'll see rectangle and square side by side. Oh, children, I forgot to ask you. I've shared my screen. It's visible, right? Oh my God. Children? Yeah. Okay. Yeah, children. So in a rectangle, diagonals are unequal. The diagonals are not equal. Diagonals not equal. Not equal. Here diagonals are equal. Diagonals are equal. Diagonals bisect each other. Of course, because they're parallelograms. No, so diagonals will bisect each other. We don't have to think twice. Diagonals will bisect. Diagonals bisect each other. Not at right angles. Not at right angles. Not at right angles. Here, diagonals bisect at right angles. Bisect at right angles. Diagonals are not equal in a rectangle. Diagonals are equal in a square. Diagonals bisect each other in both because they are parallelograms. Because a rectangle and a square, both of them are parallelograms. Diagonals will bisect each other. Diagonals bisect each other, not at right angles in a rectangle, at right angles in a square. In a rectangle, the diagonal does not bisect the corner angles. Now this corner angle is 90 degrees. This is 90. So maybe it's 70 here and 20 here. So here also this angle is 90. Everywhere it's 90. The corner angle is not bisected. It is not bisected. It will be 70 here and 20 here. This is also 90. Now tell me, will this be 20 or 70, children? This one, will it be 20 or 70? This angle, will it be 20 or 70? Okay. So class, use the emoji. Raise your hand. Swati, Bhavishya, Mritsa, Laksha, Anugraha, Sana, Niveda, Srivatsan, Prenu, Krishna Priyan. Okay. All right, children. Thank you. Yeah, my question is, this angle is 20 degrees or 70 degrees? And the answer is, it is 20 because this one is an isosceles triangle. This one is isosceles. These two sides will be equal. Because in a rectangle, diagonals are equal. Diagonals are equal and they bisect each other. See here, in a rectangle, diagonals are equal and they bisect each other. So like if this is 12 centimeters, it will be 6 here and 6 here. And diagonals are equal, no? So 6, 6 here also. So you can see that this one is an isosceles triangle. This one is isosceles. Everywhere, this side is equal. All the these four pieces are equal, So this one is isosceles, this one is isosceles, this one is isosceles, this one is isosceles. So if this is 20 degrees, this has to be 20. 70, this has to be 70. This is 20, so 20 here. The 70, so it will be 70 here. This one is an isosceles triangle. So 70, 70. Isosceles, 20, 20. Isosceles, 70, 70. Isosceles, 20, 20. So in a rectangle, the diagonals do not bisect the corner angles. The diagonals do not bisect the corner angles. When I say corner angles, I'm saying like the diagonal, no, they don't bisect the corner angles here. They don't bisect the angles at their end points. Like at the ends of the diagonal, there are two angles, right? They're not bisected. And all the four, triangles are isosceles triangles. Now in a square, there's actually nothing to find because in a square, all the angles are fixed. In a square, all the angles are fixed. Whether it is a very small square, very big square, whatever be the size of the square, in a square, all the angles are fixed. So in the sense, we know that, every corner is a right angle, right angle, right angle. Okay, and diagonals are equal. In a rectangle and in a square, diagonals are equal. Diagonals bisect each other at right angles. At right angles. So here it's all 90 here. And the difference between a rectangle and a square, is that in a rectangle, among other differences, this is not the only difference, among other differences, this is one of them. So the diagonals in a rectangle, they don't bisect the corner angles, but in a square, both the diagonals bisect the corner angles. So the 90, it will be 45 here, 45 here. So 45, 45. Diagonals, they bisect the corner angles. So 90 becomes 45, 45. So you can see that the angles are fixed. If you look at this triangle, this is 90 degrees, 45, 45. Finished. So if you're given a figure like this, and if it's given, it's a square. This is a square. Find the value of x. Given this is square. Find the value of x. X is 45. Nothing is given. No angle is normally in a figure. If you have to find an angle, something should be given, right? Some angle should be provided. With nothing, how can you find the measure of an angle? But in a square, you can find. Because in a square, all the angles are fixed. They are fixed. Either the angle is 90 or 45. Nothing other than this. It's either 90 or 45. If you're asking the whole angle, it's 90. If you're asking this angle, it's 90. If you're asking this angle, it's 45. This one is 45. So there's nothing other than 90 and 45 in a square. When we talk about these angles, these are the only possible angles. See, like if you have a figure like this, of course, the angle will change. Supposing like this, children. See here, like this. And you're asked to find this angle. Now, this will not be 45 degrees. Okay. Supposing, see here, if this is given to be, 1 second. Okay. Now, suppose this is given to be a square. Okay. Now, this angle is 90 degrees. So if they give you, they'd mark this as x. How much is this? 90, because diagonals are bisected right angles. But given this one is a square, this angle is not 90. Because there's not a diagonal. This is some line segment. This is not a diagonal. Between the two diagonals, it's 90 degrees. Now, if this angle is asked, this x, this is not 90. This is not 90 because this is not a diagonal. This is the diagonal. This one is not a diagonal. So this is not 90. Similarly, this angle is not 45. This is not 45. This one is 45. This is 45. This is 45. But this one and this one, because this is not the diagonal. So we'll have to be careful there when it comes to numerical questions. So let me clear the screen. Parallelogram, rhombus, rectangle, square. Diagonals bisect each other. Diagonals bisect each other. Diagonals bisect each other. Diagonals bisect each other. Not at right angles. Not at right angles. At right angles. Not at right angles. At right angles. Diagonals are not equal. Diagonals are equal or not equal. Rhombus. Equal or not equal rhombus? Diagonals equal. Okay. Diagonals equal. Diagonals do not bisect corner angles. Corner angles. Same thing here. The rectangle. Diagonals do not bisect corner angles. So you can remember like this. In a parallelogram and in a rectangle, only opposite sides are equal. So there the diagonals don't bisect the corner angles. But in a rhombus and in a square, all the sides are equal. So there the diagonals bisect the corner angles. The other properties are easy to remember. So don't get, you shouldn't mix up the properties, you know. And there's nothing to get confused also. It should be clear. Either you know it correctly or you don't know it. There should be nothing in between. Either you know all the properties clearly or you don't know them. So nothing, you should not get confused, muddled with the properties. It's very clear. So you can remember like this, that in a parallelogram and in a rectangle, only opposite sides are equal. Opposite sides are equal. So there, in these figures, the diagonals do not bisect the corner angles. But in a rhombus and in a square, all the sides are equal. So here the diagonals bisect the corner angles. So diagonals bisect corner angles. Corner angles, diagonals bisect corner angles. Bisect corner angles. So these are the, important or highlight properties with respect to the diagonals in these special quadrilaterals. In all the four, diagonals bisect each other. In all the four, they bisect each other. Where only opposite sides are equal, they don't bisect at right angles. Like in a parallelogram and a rectangle, only opposite sides are equal, no? So there they don't bisect at right angles. But in a rhombus and in a square, all the sides are equal. So they bisect at right angles. Diagonals are not equal in the first two, they're equal in the last two. That is where the corners are right angles. There the diagonals are equal. Where the corners are right angles, there the diagonals are equal. There the diagonals are equal. Diagonals are not equal in a parallelogram and rhombus. And again, in parallelogram and rectangle, where only opposite sides are equal, diagonals do not bisect the corner angles. In rhombus and square, since all the sides are equal, the diagonals bisect the corner angles. Okay. So, supposing the figure is given to be a parallelogram. It's a parallelogram. And in the parallelogram, if it is in a parallelogram, the diagonal do not bisect the corner angles. But suppose you are able to prove that the diagonals bisect the corner angles, then the parallelogram is a rhombus. So I think I'll not proceed meaning with the properties. We'll see it in the exercise questions where you'll be proving certain properties. All these properties, which we see here, we have the proofs in the exercise. I think the first exercise. So we'll understand there. I'll stop here with the properties. Okay. Yeah, so today I think we again saw the definitions of the different quadrilaterals and then the properties of the quadrilaterals and the different criteria, the criteria under which a quadrilateral qualifies to be a parallelogram. We saw that. Okay, so now we'll continue the exercise. So last class, we proved some results using the midpoint theorem. I think I shared the recording on WhatsApp. Did I share? Yes, because few of us couldn't take up the class. 1 minute. Yeah. Yes, I have shared. Yeah. So children, we understood how to use the midpoint theorem and the converse of the midpoint theorem in last class. I hope those who did not take up the class had time to go through the recording. Okay. Now continuing with the second exercise. We did the first and the second one in the last class. Quadrilaterals, the second exercise. We did the first two proofs. Now this is the third one. Yeah. So the results from the first two proofs in a given a quadrilateral, if you mark off the midpoints, of the sides of the quadrilateral and join the midpoints in order, the quadrilateral formed is a parallelogram. You can prove that the quadrilateral formed is a parallelogram. Any quadrilateral, ABCD is a quadrilateral. PQRS is a quadrilateral formed by joining the midpoints of ABCD in order. Given ABCD is a quadrilateral, PQRS can be proved to be a parallelogram. It's always a parallelogram. PQRS will be a parallelogram. You can prove that. So the first one was the proof based on this situation. So this situation was given, you had to prove that PQRS is a parallelogram. In the second one, we were given a rhombus. And we had to prove that the quadrilateral formed by joining the midpoints of the sides of a rhombus is a rectangle. A rhombus, it's a rectangle. Rectangle, it will be a rhombus. If you have a rectangle and you mark the midpoints of all the sides and join the midpoints in order, the quadrilateral obtained will be a rhombus, meaning it's a parallelogram. Furthermore, it is a rhombus. It is a parallelogram because any quadrilateral, this rectangle is also a quadrilateral, right? So any quadrilateral, if you join the midpoints of the sides, the new quadrilateral will definitely be a parallelogram. But if the outer quadrilateral is a rectangle, then this new quadrilateral is a rhombus. If the outer quadrilateral is a rhombus, then this inner one, the new one, is a rectangle. Rhombus, rectangle, rectangle, rhombus. Any quadrilateral, parallelogram. Any quadrilateral, it's a parallelogram. I'll just say outer and inner, okay? Outer is the given quadrilateral. Inner is inner quadrilateral is the one formed by joining the midpoints of the sides in order. So if the outer one is a quadrilateral, the inner one is a parallelogram. If the outer one is a rhombus, the inner one is a rectangle. If the outer one is a rectangle, the inner one is a rhombus. So, sometimes the numerical question can be like this. They'll give you a rectangle, this one. They'll just say that ABCD is a rectangle. ABCD is a rectangle. Find, say this length is some 20 and 10, just for example. Find the area of the quadrilateral PQRS. Find the area of PQRS. Yeah, what's the area of PQRS? ABCD. Let me make it clear, children. 1 minute. Please understand what we mean by the inner quadrilateral. The inner quadrilateral is the quadrilateral formed by joining the midpoints of the sides of the outer quadrilateral. So if the outer one is a quadrilateral, then the inner one is a parallelogram. If the outer one is a rectangle, this is a rhombus. If this is a rhombus, this is a rectangle. If this is a parallelogram, this also will be a parallelogram. If this is square, this is square. Now, my question is, ABCD is a rectangle. These are the midpoints of the sides of the rectangle. So we get the quadrilateral by connecting the sides in order. Now this one is 20 and this one is 10. Find the area of PQRS. Find area of PQRS. What is this, children? Okay. So disciplined, so quiet. I like this. Okay, children, fine. So PQRS is no, I told you, no, ABCD is a rectangle. I think I mentioned that. ABCD is a rectangle. Okay, so the quadrilateral PQRS is a rhombus. And the formula to find the area of a rhombus is half product of diagonals. Half product of diagonals. So the length of this diagonal is 20. The length of this diagonal is 10. Half product of diagonal, half D1, D2. All of us know this. Half D1, D2. So half into D1, this one, this is 20, and this one is 10. So half into 20 into 10. What is the area of the rectangle? The area of the rectangle is 20 into 10, 200. The area of the rhombus is half into 20 into 10, 100. So this is the relationship. The area of the rhombus is half the area of the rectangle. Of course, no. The area of PQRS cannot be equal to ABCD because it is inside ABCD. PQRS is inside ABCD. Then area of PQRS cannot be equal to area of ABCD. It has to be less than ABCD. And it is exactly half the area of ABCD. Because the outer one is a rectangle, the inner quadrilateral is a rhombus. PQRS is a rhombus. Area of rhombus is equal to half D1, D2, half into 20 into 10. Because if this is 20, this is 20. If this is 10, this is 10. Kindly acknowledge if this is clear, children. Please say yes or no.
Yes, ma'am.
Yes or no. Okay. All right. Thank you. Two of you acknowledge. Thank you. All right, children. Yeah. So yesterday, the second one, rhombus, we had to prove that this one is a rectangle. So to prove that this one is a rectangle, you have to first prove it's a parallelogram, and that's what we did. To prove that this one is a rectangle, you have to first prove it's a parallelogram, and that's what we did. We proved it's a parallelogram, and then we proved that this angle is a right angle. Any corner you can say, this one, or this one, any one. So we proved that this one is a parallelogram, and then we proved one of the angles, one of the corner angles is the right angle. So we proved that this one is a right angle. So it is a rectangle. We are not talking about this one. We are recalling what we learned in the last class. We are not talking about this proof. In question number 2 of this exercise, if the outer quadrilateral is a rhombus, then the inner one is a rectangle. To prove this is a rectangle, you'll have to prove that this is a parallelogram in which one angle is a right angle. So it is a rectangle. So you need to use a definition. Okay, now coming to this one. ABCD is a rectangle. ABCD is a rectangle. Okay. Yeah. PQRS midpoints show that this is a rhombus. So again, by the definition, a rhombus is the parallelogram in which all sides are equal. So now, by now, how to prove that this one is a parallelogram must be clear and easy also. You just have to connect the diagonal of the outer quadrilateral. Yes, you should be careful. You shouldn't connect. You should not join PR or you should not join QS. You must connect the diagonal of the outer quadrilateral. You must join, construction will be join AC or BD. The construction will be join AC or BD. Now, supposing we join AC. So by the midpoint theorem, you will prove that SR is parallel to AC and SR is equal to half of AC. SR is parallel to AC. SR is equal to half of AC. Children who missed last class are requested to watch that recording and then the recording of today's class after I share, if today's class is not clear. Please watch that recording and then follow today's recording. Yeah. So construction joint AC, join the diagonal of the outer quadrilateral, not inner quadrilateral. So join AC. Now prove so you take up the triangle ADC. R is the midpoint of DC. S is the midpoint of DA. Therefore, by midpoint theorem, SR is parallel to AC and SR is equal to half the length of AC. In the same way, in this triangle ABC, in triangle ABC, P is the midpoint of BA, Q is the midpoint of BC. Therefore, by midpoint theorem, PQ is parallel to AC and PQ is equal to half the length of AC. So by comparing these two, SR parallel to AC, PQ parallel to AC. So SR is parallel to PQ. SR is parallel to PQ. Comparing these two, SR is parallel to PQ. And SR is equal to half AC. PQ is also equal to half AC. Both are equal to half of AC. That means SR is equal to PQ. SR is equal to PQ. So in a quadrilateral, one pair of opposite sides are parallel and equal. Hence, PQRS is a parallelogram. In quadrilateral PQRS, in quadrilateral, not parallelogram, in quadrilateral PQRS, one pair of opposite sides, PQ is parallel to SR and PQ is equal to SR. One pair of opposite sides parallel and equal. Therefore, PQRS is the parallelogram. Now, in the parallelogram, you'll have to prove that all the sides are equal. In the parallelogram, you'll have to prove that all the sides are equal. Then it's a rhombus. But see, now I'll just number the sides 1, 2, 3, 4. Okay, but we already know 1 is equal to 3 and 2 is equal to 4 because it's already a parallelogram, right? It's a parallelogram. We just proved it's a parallelogram. That means opposite sides are equal. Yeah. So let's say this is side 1, this is side 2, side 3, and side 4. Opposite sides are equal. We've proved it's a parallelogram. So opposite sides are equal. 1 is equal to 3, 2 is equal to 4. Now, in this situation, how do we prove that all the sides are equal? So remember, when opposite sides are already equal, it's very easy to prove that all the sides are equal by just proving one pair of adjacent sides equal. Just prove side 1 is equal to 2, or 2 is equal to 3, or 3 is equal to 4, or 4 is equal to 1. When already opposite sides are equal, it's easy to prove that all the sides are equal. How? Just prove one pair of adjacent sides are equal. 1 is equal to 3. Side 1 is equal to side 3. Side 2 is equal to side 4. Opposite sides are equal. But we want all sides equal. For that, just prove one more thing. Prove that 1 is equal to 2, or 2 is equal to 3, or 3 is equal to 4, or 4 is equal to 1. One pair of adjacent sides equal. So how do we prove that? Supposing we want to prove that side 1 is equal to side 2. You want to prove that side 1 is equal to side 2. That means you should take up this triangle and show that they are congruent. So CPCT, you will get PQ is equal to QR. Okay, now I didn't tell you this. So if you prove that 1 is equal to 2, supposing you prove 1 is equal to 2, 1 is equal to 2. Now look at this, 1 is equal to 3, 2 is equal to 4, and 1 is equal to 2. That means all are equal, no? Because if 1 and 2 are equal, that means all the 4 are equal. I'm pausing so that you process. So in this situation, if you prove that 1 is equal to 2, you can see 1 is equal to 2. Both are equal then that means all the 4 are equal. So to prove that 1 is equal to 2, you need to take up this triangle and show that they are congruent. That's all. Or if you want to prove 2 is equal to 3, if you want to prove that this side is equal to this side, then take up this triangle and show that they are congruent. You can take any pair. Depending on what you want to prove. If you want to prove that PS is equal to SR, then take up this triangle and show that they are congruent. CPCT, you will get the result. And then you will say PQRS is already a parallelogram. Now we proved that adjacent sides are equal. That means all the sides are equal. So it's a parallelogram in which all sides are equal. Therefore, it's a rhombus. So now how do you show that these two triangles are congruent? Yeah. Any two, like say this one and this one, okay? So what will you say? We know that S is the midpoint of AD. S is the midpoint of AD. We know that. That means AS of this triangle is equal to SD of this triangle. Because S is the midpoint. Because it's given in the question. So since S is the midpoint, AS. Okay, AS is equal to SD. Then it's a rectangle. So opposite sides are equal. That means AB is equal to CD. Half of AB is equal to half of CD. Now what is half of AB? AP. AP is equal to half of CD. Half of CD, DR. Because midpoints, P and R are midpoints. So AP is equal to DR. AP is equal to DR. So this side is equal to this side. This side equals this side. And then corners, right angles. So SAS congruence criterion, the two triangles are congruent. CPCT, PS is equal to SR. So how do you finish it? You will say, we know that in PQRS, we know that PQ is equal to SR and PS is equal to QR. We know this. Now we have proved that PS is equal to SR. PS is equal to SR. We proved that PS is equal to SR. See, you can just take numbers to understand, children. You can just take numbers to understand. Suppose PQ is equal to SR. No, so supposing PQ is 7, then SR is also 7. Now we have proved that PS is equal to SR. So if SR is 7, PS is also 7, right? Now if PS is 7, QR is also 7. So you can see all sides are equal. All the sides are equal. So in PQRS, all the sides are equal because already opposite sides were equal. Now we proved that adjacent sides are equal. One pair of adjacent sides equal. Therefore, it is a rhombus. Yeah, please write down, children. Write down quickly. Go through. Take 2-3 minutes. Read through the slide and then write down quickly. The figure ABCD, no, it is like a parallelogram, meaning it's not like a rectangle, children. That alone corrected. Should be straight like this, no? Please correct the outer one. The outer one, ABCD, no? It's slightly slanted, like it looks like a parallelogram and not a rectangle. ABCD is a rectangle. Please draw that correctly. I'll just come back in 2 minutes. Please write. Done, children?
Completed.
Very good. Okay.
Ma'am, can you show me the last slide, ma'am?
Oh, yeah, sure.
Thank you, ma'am.
Yeah. Children, I told you to make this correction that this figure, no? This is a rectangle. The outer one is a rectangle. The outer one is a rectangle. So it should be like this. The diagram should be like this. This one is like slanting. This doesn't look like a right angle here. All right. So this one is a very simple proof. I'll tell you what is given. We're given a trapezium. You can see here parallel lines. AB is parallel to CD, so it's a trapezium. Also, L is parallel to AB. That's also given to you. ABCD is a trapezium with AB parallel to CD, given. Now this line L is parallel to AB. This line L is parallel to AB. It's also given that E is the midpoint of AD. You have to prove that F is the midpoint of BC. E is the midpoint of AD is given. You have to prove that F is the midpoint of BC. So to prove that F is the midpoint of BC, you have to use the converse of midpoint theorem, because midpoint theorem is given two midpoints. Given two midpoints, you will get a set of parallel lines. Something is parallel to something, and it's equal to half of that third side. But if you want to prove that F is a midpoint of BC, you have to use the converse of midpoint theorem. Converse of midpoint theorem. So see, very simple. First, take up first one thing you know is because AB is parallel to CD given and AB is parallel to EF given, CD is parallel to EF. CD is parallel to EF. Because when A is parallel to B and A is also parallel to C, it means B is parallel to C. If A is parallel to B and A is parallel to C, it means B is parallel to C. So CD is parallel to EF. That means all the three lines are parallel to one another. All are parallel to one another. Now take up the triangle ABD. ABD. What are the sides of this triangle? AB, BD, and AD or DA. So E is the midpoint in triangle ABD. E is the midpoint of AD. And there's a line through E. Through the midpoint, there's a line parallel to the second side. Through the midpoint, so you can just call this point G or something. Through the midpoint E, there is a line EG parallel to the second side AB. Then by converse of midpoint theorem, G is the midpoint of the third side BD. See, to use the converse of midpoint theorem, you need to have two things. A line through the midpoint of one side of a triangle parallel to the second side. These two should be there. Bisects the third side is the result. Bisects the third side is the result. The line through the midpoint of one side of a triangle. So you should take a triangle. You must know the midpoint of one side of the triangle, and through that midpoint, there should be a line parallel to the second side. If this is given to you, then the result is that line bisects the third side. So in triangle ADB, E is the midpoint of AD, and through the midpoint E, there is a line EG parallel to AB. EG is parallel to AB. Because this L is parallel to AB, no? L is parallel to AB. That means EG is parallel to AB. So E is the midpoint of AD. Through the midpoint E, EG is parallel to AB. We have both this. So the result by the converse of midpoint theorem is that G is the midpoint of BD. G is the midpoint of BD is the result. Now take up this triangle. The other triangle you see. Take up this triangle. DCB. Now we have proved that G is the midpoint of BD. We just proved G is the midpoint of BD. We just proved. Now G is the midpoint of BD. Now through G, we have a line parallel to the second side CD. Through G, we have a line parallel to CD, the second side CD. So in triangle BCD, G is the midpoint of BD. Through the midpoint G, we have GF parallel to the second side DC. All the three lines are parallel to one another. So GF is parallel to DC. We have both this. So by the converse of midpoint theorem, F is the midpoint of BC. That means by the theorem, it bisects the third side. The line through the midpoint of one side of a triangle parallel to the second side bisects the third side. That means the third side is cut into two equal parts, which means F is the midpoint of BC. Yeah, please write down, Chetan. Finished, children? I said because it's NCRT, you can just take down the proof. Finished?
Yes, ma'am.
Yes.
Okay. All right, children. Here also, the diagram is not very appropriate. 1 minute. This should be like here. F is the midpoint. Don't mind, okay? This is the midpoint. F is the midpoint of CD. E is the midpoint, children. Doesn't look like that, but it is the midpoint, okay? So let me tell you what is given. So ABCD is a parallelogram given. Given ABCD is a parallelogram. Given E is the midpoint of AB. Given F is the midpoint of CD. Now you need to prove that. Can we see this diagonal BD? We should prove that this diagonal BD is cut into 3 equal parts. DP, PQ, and QB. We must prove that the diagonal BD is cut into 3 equal parts. DP, PQ, and QB. So which means we'll have to prove that DP equals PQ and PQ equals QB. Then this means DP is equal to PQ is equal to QB. That means DP is trisected. Diagonal BD is cut into 3 equal parts. We should prove that. That means you should prove that DP is equal to PQ is equal to QB. So to show that 1 is equal to 2 is equal to 3, show that 1 is equal to 2 and 2 is equal to 3. Therefore, 1 is equal to 2 is equal to 3. Okay. Again, very simple proof. Listen very carefully. Now, we need to first prove that this quadrilateral is a parallelogram, children. We need to first prove that this quadrilateral is a parallelogram because we want parallel lines. Once you prove that this is a parallelogram, opposite sides are parallel, right? In a parallelogram, opposite sides are parallel. So because we want parallel lines, that's why we prove that AECF is a parallelogram. Okay, AECF is a parallelogram. Why? Because then you'll have parallel lines, opposite sides parallel in a parallelogram. Now, to prove that AECF is a parallelogram, we use the property that in a quadrilateral, if one pair of opposite sides is parallel and equal, then it's a parallelogram. So we're going to prove that AE is equal to FC and AE is parallel to FC. One pair of opposite sides parallel and equal. So we have to prove that this one is a parallelogram. AECF. This one is a parallelogram. For that, prove that one pair of opposite sides parallel and equal. Therefore, it's a parallelogram. Okay. So in quadrilateral AECF, we know that in the figure we know that AB is equal to CD because it's a parallelogram. Opposite sides are equal. So half of AB is equal to half of CD. So since E is the midpoint, half of AB is AE. And since F is the midpoint of CD, half of CD is CF. So we proved that AE is equal to CF. Now AE parallel to CF. Yeah, AE is parallel to CF because the whole thing is a parallelogram. So obviously these two are parallel because ABCD is a parallelogram. ABCD, this whole thing is a parallelogram. So opposite sides will be parallel. Hence, this is parallel to this. AE is parallel to FC. So in the quadrilateral AECF, one pair of opposite sides is parallel and equal. Hence, it's a parallelogram. Now, after proving that it's a parallelogram, take up the triangle DQC. Children, first take up the triangle in which F is a midpoint, and then another triangle in which E is the midpoint. See, we only know these midpoints, right? We know that F is the midpoint. So take up a triangle in which you can include this side, F midpoint of DC. So you have to take up the triangle, this one. See, I'll make it more easy. You want to prove that DP is equal to PQ. And you also know that DF is equal to FC. DF is equal to FC. Because F is the midpoint is given. So put everything together. That means you'll have to take up this triangle DQC. In triangle DQC. So in triangle DQC, F is the midpoint of DC. And since we've proved that it's a parallelogram, FP is parallel to, we prove that it's a parallelogram. This one is a parallelogram. So that means FP, this one is parallel to this one. FP is parallel to QC. So in the triangle, F is the midpoint of CD, and there's a line through F parallel to the second side, CQ. So by the converse of midpoint theorem, P is the midpoint of DQ. You should take a triangle in which you know the midpoint of one side, and through that midpoint, there should be a line parallel to the second side. If you have this, then the result is that line bisects the third side. So we took up this triangle DCQ. F is the midpoint of DC. And through F, we have FP parallel to CQ. Because we have proved that this one is a parallelogram. This whole thing is a parallelogram. So F is the midpoint of in this triangle. In this, sorry. Yeah. So in this triangle, F is the midpoint of CD and FP is parallel to CQ. Therefore, by the converse of midpoint theorem, P is the midpoint of DQ. P is the midpoint of DQ. That means DP is equal to PQ. Now take up this triangle. So you can get the result PQ is equal to QB. PQ is equal to QB. Now we got DP is equal to PQ. Now we'll get PQ is equal to QB from this triangle. So here E is the midpoint of the side AB. EQ is parallel to AP because we proved that this one is a parallelogram. EQ is parallel to AP. Therefore, by the converse of midpoint theorem, to use the converse, you need midpoint and a line through the midpoint parallel to the second side. Then it bisects the third side. So the third side is BP. It's bisected. Q is the midpoint of BP. So we proved that P is the midpoint of DQ, which implies DP is equal to PQ. And then we proved that Q is the midpoint of PB. Q is the midpoint of PB. So this implies PQ is equal to QB. So by comparing DP is equal to PQ, PQ is equal to QB. So DP is equal to PQ is equal to QB. Any questions, children?
No doubts, ma'am.
Very nice. You can just write down, and if you have any clarifications, you can ask me. Please write, children. That makes it very clear. Please improvise the diagram. This F should come here like this. F and E are the midpoints, but they don't look like. So just improvise the diagram, put the midpoint here correctly. E and F, just change the position of E and F. So I told you we start off by proving that this one is a parallelogram. For the need of parallel lines, we want parallel lines. That's why we prove it's a parallelogram. We prove that this one is a parallelogram by showing that this one is parallel and equal. So it's a parallelogram. But now that it's a parallelogram, both the pairs of opposite sides are parallel. So this one is parallel to this one. So now these parallel lines we use in the converse of midpoint theorem. See, for in this triangle, we take up this is parallel to this because this whole side is parallel to this whole side. No. So we take a part of it. This one is parallel to this one. Because the whole side of the parallelogram is parallel to this side. Then when you take up this triangle, EQ is parallel to AP because these full sides, they are parallel. But we need only EQ parallel to AP. Okay. So for the need of parallel lines, yeah, please write down, children. Okay, so you can see here AB is equal to CD. Why? Because opposite sides of parallelogram equal. When do you use this half of, AB equal to half of CD? Only if you know the midpoint of AB and CD. Because only if you know the midpoint, you can write its half, right? Simply, we cannot write AB may be equal to CD. If you know the midpoint of AB and the midpoint of CD, only then you can say half of AB. See, half of AB is equal to half of CD. That's true. But when you use that, only if you know the midpoint of AB and the midpoint of CD. If the midpoint of AB and CD are not given, then there is no point writing half of AB is equal to half of CD. So here we know F is the midpoint of CD and E is the midpoint of AB. So AB equals CD because the opposite sides of parallelogram ABCD are equal. Half of AB equal to half of CD. Now half of AB, this is AB, and E is the midpoint. So half of AB will be AE or EB, but we'll write AE equal to half of CD, which is CF. So in this quadrilateral, we have proved that this side is equal to this side. AE is equal to CF. Now we'll have to show that AE is parallel to CF. AE is parallel to CF because AB is parallel to CD. Because AE and CF are a part of AB and CD. AE is a part of AB and CF is a part of CD. Since AB is parallel to CD, AE is definitely parallel to CF. Because if two things are equal, any part of them are also, when two things are parallel, any portions of them are also parallel. So like if this is parallel to this, then PQ will also be parallel to AB. PQ can be a bigger line segment than AB. When we're talking about parallel lines, the length is not important. They're parallel. That means they don't meet. They will not meet even if they're produced either ways. Parallel has nothing to do with equality. PQ may be a bigger line segment than AB, but they can be parallel. Okay, so like this, we prove that opposite sides are parallel and equal. So this one is a parallelogram. So it's a parallelogram. So now this side is also parallel to this side because it's a parallelogram. These two sides are parallel. So when you take up this triangle, you will say F is the midpoint of CD. FP is parallel to CQ because the whole sides are parallel. So by the converse of midpoint theorem, this one is the midpoint of DQ. Then you will take up this triangle in which E is the midpoint of AB. Through EQ is parallel to AP because these two sides are parallel. It's a parallelogram. So EQ is parallel to AP. Through the midpoint E, we have a line parallel to the second side AP. So by the converse of midpoint theorem, Q is the midpoint of BP. So from the first one, we have DP equals PQ. Second one, we have PQ equals QB. So you have PQ here and here. That means all the three are equal. So the diagonal is trisected. If you're asked to prove that DP is equal to 1/3 of DB, prove that DP, supposing you have to prove that DP is equal to 1/3 of 1/3, not half, sorry. If you're asked to prove that DP is 1/3 of DB, then you just have to write a few more steps. You must write DP. After proving they're equal, you must continue. DP plus PQ plus QB is equal to what? DB. DP plus PQ plus QB is equal to the whole diagonal dB. But all these three are equal, no? So you can add dP plus dP plus dP because all these three are equal is equal to dB. 3 times dP is equal to dB. Therefore, dP is equal to 1/3 of dB. Sometimes you'll be asked to prove this result, or they'll say prove that PQ is equal to 1/3 of BD. For everything, the steps are the same. I'll let you know. Next one. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral. Okay, so the given figure is a quadrilateral. So let's call it ABCD. We'll mark the midpoints P, Q, R, S. The line segments joining the midpoints of the opposite sides. AB and CD are opposite sides. This is the line segment joining their midpoints. BC and AD are opposite sides. This is the line segment joining their midpoints. You must prove that the line segments bisect each other. You must prove that PR and SQ bisect each other. Bisect each other. You must prove that PR and SQ bisect each other. But we know that in a parallelogram, the diagonals bisect each other. In a parallelogram, diagonals bisect each other. We know that. So what you should do is, you must make these line segments PR and QS the diagonals of a quadrilateral. You must make them the diagonals of a quadrilateral. So that you can do by joining PS, PQ, QR, and SR. Now, when you join like this, PR and SQ are now the diagonals of the quadrilateral PQRS. Earlier, we did not have this quadrilateral PQRS. We had to prove that PR and SQ bisect each other. So we thought, okay, if PR and SQ, if we have to prove that they bisect each other, we'll make them the diagonals of a quadrilateral. We'll make them the diagonals of a quadrilateral by joining P to Q, Q to R, R to S, and S to P. So now if you prove that PQRS is a parallelogram, then by the property, PR and SQ will bisect each other. Because in a parallelogram, diagonals bisect each other. So here we'll just prove that PQRS is a parallelogram. So once you prove PQRS is a parallelogram, diagonals PR and SQ bisect each other. Because that's a property of a parallelogram. Diagonals bisect each other. So now to prove that PQRS is a parallelogram, you need to connect the diagonal AC or BD, any one. connect the diagonal AC. Always connect the diagonal of the outer quadrilateral. Now that need not pass through this point. Don't think when you join this, it should pass through this point. That it need not. It may not. So Krishna Priyan, tell me, in triangle ABC, continue, in triangle ABC. Yeah, somebody tell me what I'm expecting.
Ma'am, Q is midpoint of AC.
Q is the midpoint of BC, okay?
Ma'am, P is the midpoint of AB.
P is the midpoint of AB. Okay, so you have two midpoints. Then will you use the midpoint theorem or converse?
Converse midpoint theorem.
Midpoint theorem.
Midpoint theorem. If you have two midpoints, use the midpoint theorem. So by the midpoint theorem, yeah, what's the result? Which is the line segment joining the midpoints? QP.
PQ.
PQ. Okay, so PQ is?
Line segment joining the midpoints of side AB and BC.
Yeah, the result is PQ is parallel to?
And half of AC.
Yeah, PQ is parallel to the third side AC and PQ is equal to half the length of the third side AC. In the same way, we can prove that in triangle, which is the triangle we should take now in triangle.
ADC. ADC.
ADC, in triangle ADC. Tell me the midpoints.
Ma'am, S is the midpoint of AC, ma'am.
S is the midpoint of AD.
R is the midpoint of
R
DC.
is the midpoint of P.
R is the midpoint of DC. So now this line segment joining the midpoints. So by midpoint theorem,
SR is parallel to AC and half of AC.
very good. SR is parallel to AC because in triangle ADC, which is the third side, in this triangle ADC, this is the midpoint of one side, this is the midpoint of the other side. So the lines, this line segment joining the midpoints will be parallel to the third side. So SR is parallel to AC and SR is equal to half the length of AC. So SR is parallel to AC, PQ is parallel to AC. That means SR is parallel to PQ. SR is parallel to PQ. SR is half AC. PQ is also half AC. That means SR is equal to PQ. So in PQRS, in the quadrilateral PQRS, one pair of opposite sides is parallel and equal. Therefore, PQRS is a parallelogram. Now, once you prove it's a parallelogram, the diagonals PR and QS will bisect each other. Hence proved. Yeah. Yeah, please write down, children. I think when I explained, I connected the diagonal AC here, diagonal BD is connected, anything. So here you will prove that PS is parallel to RQ and PS is equal to RQ. Hope you're all writing, children. Please write. Done, children? Finish writing, children?
Yes.
Okay. Okay. We'll just do this one and wind up the session for today. Just a second, children. Yeah, thank you, children. Yeah. So in this question, ABC is a triangle right angle at C. ABC is a triangle right angle at C. A right angle at C. Okay. Okay. A line through the midpoint M of hypotenuse AB. Midpoint M of the hypotenuse AB parallel to BC. A line through M. A line through M parallel to BC intersects AC at D. Intersects AC at D. Show that D is the midpoint of AC. That's the direct result by converse of midpoint theorem. In this triangle, M is the midpoint of AB, MD is parallel to BC. Therefore, by the converse of midpoint theorem, D is the midpoint of AC. That's a direct result by the converse of midpoint theorem. Then we need to prove that MD is perpendicular to AC. MD is perpendicular to AC. MD is perpendicular to AC. That's also easy because we already know MD and BC are parallel lines. These two are parallel. So this is the transversal. Corresponding angles are equal. Or you can say co-interior angles are supplementary, whatever. Co-interior angles are supplementary, so this is 90. Or corresponding angles are equal, so this is 90. Since we know since it's given that MD is parallel to BC, this is the transversal. This is 90. So this also will be 90. Corresponding angles are equal. So that way you can say that MD is perpendicular to AC. MD makes right angles with AC. Next, you have to prove that CM is equal to MA. CM is equal to MA. We'll do this. We'll do meaning two at a time. We'll not take this now. We'll have to prove that CM is equal to MA. So CM, we don't see that line segment at all. Where is CM? Here there is C, here there is M. So you should join to see CM. You must join CM, join CM. So you should prove that CM is equal to MA. CM is equal to MA. So that means you should show that these two triangles are congruent. So CPCT, you will have CM is equal to MA. You will have to show that this triangle is congruent to this triangle. Then you will get the result by CPCT that MA is equal to CM or MC. Now we know that CM is half of AB. We know that there's nothing to, not CM, sorry, AM. There's nothing to prove there. There's nothing to prove there. MA is half AB, that we know, no? MA is half of the whole line segment AB. Because M is the midpoint. M is the midpoint of AB. So AM is half of AB. We know that already. Because M is the midpoint of AB. So MA is equal to half AB, we know. Because M is the midpoint of AB. MA is half of AB. See, if this AB, if this full thing is 10, this is the midpoint. So it will be 5 here and 5 here. So MA is half of AB, correct? Now we proved that MA is equal to MC. So we proved that MA is equal to MC by congruency. And we know that MA is equal to half of AB. So comparing all, from these results, we can conclude that MA is equal to MC is equal to half AB. So prove that MA is equal to MC through congruency. then MA is equal to half of AB is simple because M is the midpoint of the hypotenuse AB. So MA is equal to half of AB. So now from these two results, MA is equal to MC is equal to half AB. Yeah, children, please write down. Done, children? Finish writing, children?
Yes, ma'am.
Okay. That was Mritsa. What about the others? Okay, take a screenshot, children. In case you have not finished, you might have a little more to complete. If you have not finished, please take a screenshot. All right. So in the next class, we shall see some numerical applications of these theorems. The converse of midpoint theorem, and a few other properties of quadrilaterals which we have seen so far, all these can be very useful in numerical situations. So we'll see them in the next class. All right, children. Oh, okay, before that, you use the emoji, raise your hand, children. How many of you at the end of the meeting? All of you, Krishna Priyan, Bhavishya, Mritsa, Laksha, Niveda, Sahana, Anugraha, Swati, Renu. So Srivatsan was there, he's not there. Can't make out anybody else. think the others are all there. All right, children. Thank you so much. That's it for today's session, children. You may leave the call. Good night.
Thank you, Mommy.
Thank you, children. Good
Thank
night.
you.
Thank you, children.
Thank you, ma'am.
Good night. Good night, children. Thank you.